Everyone, we are here to understand Azure Virtual NAT Gateway today. This is a new resource in the Azure. It wasn't there before, but let's understand what it is and what kind of help it provides to the architects or to our Azure environment. All right, so we'll go through this architecture later. First, try to understand what is NAT Gateway. So in whole and soul, NAT Gateway provide outbound internet connectivity. Let me tell you again, it provides outbound only internet connectivity for one or more subnets of a virtual network. So it is like when you create a VM, okay? First, let me write it down here. Outbound only internet connectivity to one or more subnets. So you're not attaching it to a VM, you're not attaching it to your virtual network entirely, but to the subnets. The thing is that you can attach a single net to the multiple subnets, or you can attach separate NAT gateways on a separate subnets of a single virtual network. You cannot attach to a multiple virtual network, okay? Single gateway. So that's how it is. Now let's try to understand this. Let's suppose this is our virtual network in Azure, and we have this simple virtual machine. All right, and this machine doesn't have the public IP address. Okay, it has only the private IP address. So by default, this machine can talk to the internet. Okay, and from where it is going on the internet, that netting is done by Azure backend. You can go and check by like what is my IP address, and you can get the public IP address of that by which you are going out to the internet. Okay, private IP. Let me write this down here. IP Azure takes care of internet by default. All right. It's simple. Okay. Now let's suppose you have a public IP on this VM. Okay, let's suppose there is one more VM. Come on, what's wrong with you? Okay, suppose there is one more VM and we have a public IP on it. Okay, now how things will go? In that scenario, when it has a public IP address connected to the NIC of this VM, then the outbound flow to the outside world or the internet will not taken care by Azure, but this IP will take the precedence. Okay, this IP will supersede the route. Now the VM will go through go through this IP rather than going by Azure backend. Okay, public IP always takes the precedence. It will rewrite the routes and it will not go out to the internet via the Azure IP addresses that they has for their netting, but through this public IP. Okay, now let's suppose this public IP is attached to a load balancer. Okay, or let me create one more. Let us make a little bigger. Now we have this VM, and this VM has some load balancer. There is some load balancer which has public IP address, and this load balancer is, and this VM is behind this load balancer. Okay, even in this scenario, VM will go out through this public IP address, this one, from the load balancer's IP address. Okay, if it is basic, but if it's standard, we create the outbound rules. Okay, we know that we can specify those. Now, if you apply the NAT gateway, okay, then this will take overtake all the routes. Okay, if you have a VM with the public IP, or I can let's say this way, this NAT gateway is compatible. That's the right word. Compatible with these things: standard load balancer, standard public IP, and standard public IP prefix. We have covered the public IP prefix in the last video. Okay, so it can it is compatible with this. That means if this load balancer is standard, this is a standard load balancer, then the outbound would be taken care by the NAT gateway. Okay, outbound traffic flow will taken care by the NAT gateway. Okay, NAT gateway public IP is the point. Okay, so we can say static IP address come from public IP address resources, public IP prefix resources, or both. What I'm talking about, the static IP that NAT gateway has. It would have public standard PIP, okay, to go to the outside world, and this will provide the source network address translation for this VM behind the standard public load balancer or standard PIP or standard prefix. Okay, but this would be attached to the subnet, and this will specify which static IP address virtual machine use when create the outbound flows. For example, if it is not there, if this is not there, then it will take this route. Okay, but if NAT gateway is attached to the subnet, then the outbound flow will be taken care by NAT. Okay, cool. Now let's understand NAT gateway can be zonal or regional. By default, this is a regional resource, but you can make it zonal as per your architecture. If you're designing that way, for example, we have subnets. Virtual network is also regional. Okay, subnets are also regional, but what you can do, you can keep your compute resources in the different zones and apply NAT gateway, a single NAT gateway to the particular subnet of that zone. What I'm trying to say, virtual network is regional, subnet is regional, but you can define subnet 1 where these two VMs belong to zone 1 and subnet 1 is for these VM. Subnet 2 may belong to zone 2 only where these VMs are. And you can attach different NAT gateways here and here. That's how you can make it zonal. Now, once you associate the NAT with subnet, then it is defined with a property on a subnet within a virtual network. That means outbound connectivity will use IP address associated with NAT gateway as the source IP address. All right. Cool. Now, let's try to understand if there is a virtual network NAT and VM with instance level public IP address. These scenarios, they're going with these scenarios again to make the things absolutely clear for all of us. Now, let's suppose there is a NAT with VM with instance level public IP. This is the scenario. Now, what would happen? The inbound would come from PIP, public IP, but the outbound will go through NAT gateway. Okay. If there is no NAT gateway, then single point would be incoming and outgoing. If there is no public IP, then there is no incoming, but outgoing will go through the Azure NAT, this scenario that we talked. Now let's suppose there is a public IP on VM and NAT is there, then incoming would be from this IP, but the outgoing will go through the NAT. Okay, through the NAT. In this scenario, when there is a public IP attached to the VM. Now let's go to this instance, virtual network NAT with public load balancer. Sorry, there, public load balancer. Okay, now here inbound would go through public load balancer, but outbound will go through the NAT gateway. Any outbound configuration from a load balancing rule or outbound rules is superseded by NAT gateway. If NAT is there, then NAT wins. In what situation? If there's a public IP over the VM or there is a public load balancer VM behind the public load balancer, in both the cases. Now let's see the third one. There is a NAT right here and VM with instance level public IP and public load balancer. Okay, so this VM, there is a public load balancer and there is a public IP as well to the VM. Then inbound through VM instance level public IP. Okay, let me add here. Let me add PIP on the instance level as well. There is a PIP on the instance. Now inbound will go through the instance level PIP. And public LB IP, but outbound will go through NAT. So in all these things, all these three scenarios that we started this video with, we understood if there is a NAT, NAT will supersede all the outbound routing. Incoming will remain the same. Okay, but there is a catch. If it is a basic load balancer, then NAT gateway cannot hamper or change or supersede the route. If there's a basic load balancer with the basic public IP behind, there is a VM, it will go through the load balancer and even inbound through the same PIP and the outbound through the same PIP. NAT will not impact that scenario. That is the reason the basic SKU of these services must be deployed on a subnet without a NAT gateway. This separation allows both SKU variants to coexist in the same virtual network. Okay, and we already talked about it so many times. Standard doesn't work with basic, and basic doesn't work with standard. Let's put the same concept here. All the standard IP, standard public IP, and load balancers NAT gateway works with. That's why all the routes would go through NAT if NAT is there. But if it is a basic, it will not. So we need to place basic in a different subnet where we have not attached the NAT. Okay, cool. Now, let's understand a few more things. Okay. Now, let's try to understand SNAT first, source network address translation. Okay. What happens? Let's put one more example here to understand this. Let's suppose there is a source VM. Okay. And traffic generates from here and going in the outside world like this. Okay. Now, what SNAT does, it rewrites the source of a flow to originate from a different IP address. For example, this VM has some private IP address. Okay. And we have public IP address here. So what SNAT will do for outside world, it would not show the private IP address, but this public IP address. Okay, so it rewrites the source of a flow to originate from a different IP address. That's the common translation, address translation. Okay, source address translation. Now, if we talk about NAT gateway resources, NAT gateway resources use a variant of SNAT. Okay, they use PAT. It's a variant of SNAT and it uses port and call it port address translation. Okay, PAT. And PAT rewrites the source address and source port, not just the IP address, but the source port address, source port as well. So with SNAT, there is no fixed relationship between the number of private addresses and their translated public addresses. All right. So let's take an example of flow to explain the basic concept. Then let's suppose, let me make it this. All right. Let's suppose, let me make here. Let's suppose there is a NAT gateway. And this PIP is, this PIP belongs to the NAT gateway. Okay. All right. And there is a VM. Now, let's suppose the IP of NAT gateway is, let me make this as an IP, public IP. Let's suppose this is 30.40.50.60. Okay, and the private IP of this VM is 10.10. 20.20. Okay, now this IP and this IP. So what the SNAT will do for outside world, it will appear the traffic is coming from this source, but actually it is from here. Okay, now what the PAT will do, it will also add the port. For example, 4284. Let's suppose this is the port, and there would be another port here. Let's suppose this. Okay, and wherever is the destination, let's suppose this is the destination, and its IP is something like 40.40.40.50, some public IP, and there would be some port 80. Okay, like this. So it will also attach the port. All right, so if there are 4 different IP addresses of source, okay, let's suppose 10.10.10.1, okay, and it will go through some port, let's suppose 4000. Okay, let's suppose, come on, this is the first IP, this is our second source, this is third source, this is our fourth source. So what is going to change here? This is the second, this is the third, and this is the fourth. Similarly, a single port attached to single source, not just with the IP addresses, but with the ports. Now, this would look like your source. Okay, this is your source. Now, how the NAT gateway will look like? I'm sorry. Now, let's suppose this is the NAT. This is our NAT gateway, and it has some IP addresses, right? 30.40.50.60. It will look like with different ports. 234. Let's suppose copy. For this, it would be a different port. For this, it would be a different port. For this, it would be a different port. Okay. Now, let's go to the destination. This is the destination. Okay. Let's suppose it's something like x.y.z.a on port 80. Let's put it like this. This is the destination. So how the things are happening now? Like this. And that's how it is connecting, not with just the IP address, but through the port. So that's how the PAT works. Not with the IP address, but with the port. So it will go through 4000 through 234, and that's how it come back. And that is the reason we also have that idle timeout concept here as well. Once the idle timeout is over, it can assign this port to the another one as well. Okay, cool. Now, let's talk about few limitations. For example, we already talked about like NAT gateway is not compatible with basic resources, and it only works with IPv4 address family, not the IPv6. And NSG flow logging isn't supported when using NAT, and single NAT can span multiple virtual networks. There is one more thing. Uh, it's good to know information. To optimize the cost, always use service endpoints and private links. Okay, because when you access Azure storage and you enable the service endpoint for storage, what it will do, it will avoid data processed net charges because service endpoints are free. When you enable the service endpoints, it will go through the service endpoints. Okay, it will not go through net. Okay, to the backend of the Azure. That's why. Same applies to the private link. Private link exposes Azure PaaS services as a private endpoint inside a virtual network. So private link is built based on duration and data processed. Okay, these can help you to optimize cost as well. Well, this is the concept of NAT gateway. We try to understand the entire architecture and how it works, how traffic flows. Hope it would help. I'll share the documentation link in the description box, and we'll do the demo part in the next video. Thank you for watching. Have a good day.